All right, hello. Hope you guys are doing well. Thank you for attending my session. My name is Roland Lee, and I'm head of the products at Heimdall Data. And I'm really pleased to be here to share with you how you can improve your application performance through SQL auto caching without any code changes. So I'm going to make this, since we're a good group here, we're going to make this discussion oriented. And so if you have any questions, feel free to raise your hand and we can have a good discussion. So the agenda for this afternoon, we're going to talk about two things. We're going to give you an introduction of what a database proxy is, and number two, I'll give you a demo. Web challenges. So when developing web applications, as you have more users, it results in more application instances, which means higher data volumes, more tables, more schemas. And I have highlighted here something that's often neglected, which is high latency responses. And so CDNs and caches, HTTP caches, solve a lot of that latency. But what people often forget is the latency on the back end. And that is the latency between the application and the database, especially in the cloud. So as you deploy application instances and database instances in the cloud, they can be geographically dispersed. And that latency, that round trip time between the application and database could slow down the application dramatically. And that's something that developers and application owners should make note of. And this is a pain point for which Heimdall Data is trying to solve. So I want to introduce, have you guys heard of a database proxy before? Anyone has heard that? Okay. What I've done here is just lay out some of those in the market. They're all good, they're solid, and I would recommend them. There's Proxy SQL, which is an open source. There's MariaDB, which is based off of, I believe it's called MaxScale, is their database proxy. There's ScaleArc, and then there's Heimdall Data. Basically, most of them, what they can do is they can do a set of features, automated failover. What that means is if there's one database instance, whether it be a read or a write, it can automatically fail over to the replicate database instance. There's read-write splitting. Do you know what read-write splitting is, by any chance? What that term is? Well, read-write splitting is the ability, when you want to scale out horizontally, what you want to do is you want to, sharding is one way to scale out horizontally, but there's another ways by which you separate the writes from the reads. And so the application, if you're a developer and you don't have, you want to create a logic that will be able to route the queries, the write queries to the write server and the reads to the read servers. So read-write splitting is that. It's basically query routing, being SQL aware and routing the right query to the right database instance, if that makes sense. The other feature that we're going to be talking about is automated caching and validation. And this is what makes Heimdall Data unique compared to all the other features. Does anyone use MySQL today? Yep. Okay. MySQL query cache, unfortunately, was deprecated last year. And let me explain a couple of reasons why it's not supported anymore. For one thing, it just didn't scale. It didn't work because it's caching on the database side. And that only solves one issue, which is it increases database scale, it increases database processing, but you still have that round trip time. The application still needs to go to the database, it's going to be served out from cache and go back. And that's not the most scalable. And so it just didn't work very well. And it wasn't, and then the second thing that it didn't do is it didn't do any invalidation. Okay, so you can't have caching without invalidation. So what do people do today? They're really creating that logic, which takes a lot of headcount, a lot of resources, and we took a survey. We found out that the average percentage of development resources to create and sustain a cache subsystem is 20% of a developer's time. So that's 1 day a week, just to maintain a cache subsystem and just with tuning it, adapting it to the traffic that might change. That's a lot of development resources. And then lastly, and I'll talk about it, is that not only do we automate caching and validations, but we also reduce network latency, and I'll explain that. So what does that have to do with in-memory data computing? And this slide I think is important. When do you use a database proxy, and when would you use in-memory data grid as a primary store? This is Roland's suggestion and recommendations. For the best scale and performance, go with an in-memory data grid, right? For whether it be Hazelcast, Oracle, Redis, you're gonna get the best scale and performance. You have the most control, okay? Typically, this is for greenfield applications. You're starting from scratch and developing the application, okay? And so you're not coming in midstream. And the con of this is it takes a lot of code and development work. So you're committed. You're committed to that vendor, and you're going to go all the way through. So you put a lot of work, but you get a lot of benefit, okay? So that's just a profile of in-memory data grid. However, if you're not familiar with these vendors and you don't, you find it's a bit risky, maybe tying into a particular vendor, what if I said, well, I'm not going to give you the best, proxies aren't going to give you the best performance, but it's going to give you good performance. How about if I said it gave you 70% of the way there in terms of scalability and performance? Then that may become interesting, okay? Because it requires no code changes. So any of these, you just drop them in, probably takes about 20 minutes, and you're done. You get the caching, you get the failover, you get the read-write splitting, and away you go. So best performance takes dev work. You get some pretty good performance, no code changes, okay? And the profile is different in the sense that this, on my left, you're right. Proxies are typically for existing applications, okay? Maybe the developer is no longer there, and maybe you don't want to invest resources into rewriting the code. Proxies are the way to go, okay? Any questions on this? This is a good way, this is my way of sort of distinguishing the two. You could still use in-memory data grid for proxies, but you would use this for caching, not for a primary data store. And so this would be possibly using a proxy with in-memory data grid could probably get your feet wet and you can familiarize yourself with an in-memory data grid before you go all the way and use that as a primary data store or database. Any questions on this? Yes?
Where do you place times 10?
Times 10?
Because it can front end or...
It's sort of in the middle. Yeah, yeah. It's definitely here, but it can take on some of that functionality as well. Yeah. Okay. Now, for Heimdall data, what makes it, the reason why it doesn't require any code changes is that we offer it in a couple packages that make it very, very nice. Does anyone use JVMs at all? Deploying JVMs? Okay. As a JVM on my right, or on your right, it's just a jar file. So it's a JDBC driver that you put in between your application and your current vendor JDBC. So we support basically any JDBC-based database, if that makes sense. So you just change a class path URL. If you're not JVM-based, we have these database proxies, which is a Postgres proxy, a MySQL proxy, and a SQL Server proxy. This is basically a sidecar process. It runs as an agent that you drop in the app server, and you just point the connection string. It's a networking change. So the application used to point to the database. Now you just point to our proxy, and the application thinks we're the database, and then we will talk to the database on behalf of the application. Okay? What makes Heimdall data unique is that we are optimizing SQL from an application perspective. Okay? We are not caching and doing failover on the database side because that, again, that doesn't remove the network latency. Notice where it's deployed. We're deployed on the edge. We're deployed on the application instance. So there's a single proxy or a jar file on every single application instance. This makes it very elegant from an operational standpoint in the sense of scale, of capacity planning. There's no more managing of figuring out what's the bandwidth, how many queries. It's just a one-to-one. For every application host, there is a Heimdall data proxy. Okay? If you have 1,000 application instances, you have 1,000 proxies. The math is very easy to do. There's no calculus to it. Okay? And so you can think of it this way. If you were to deploy caching on Heimdall data, a lot of the queries that would have gone to the database doesn't even see anymore. So for MySQL query cache, that's deployed here. And that defeats the purpose of, in other words, it makes database processing faster, but it doesn't make the application faster because of the round trip time. Here, the cache is in the application tier. You okay here on this type of deployment? It's a distributed deployment for SQL optimization. Yes?
There is a deployment that maybe you'll be getting into that in later slide. I'm just asking, right now the way I see it is at the end of database proxy, which is sitting either as a jar as a separate agent. It's kind of a shared nothing kind of a thing, meaning a cache, this cache doesn't see the other cache, that cache doesn't see the other cache.
I will answer that question. Yeah. So it is shared. There is a communication between the caches. Yeah, and I'll get to that. Good question, though. Good question. We're okay? All right. So let's go to the use cases, and I'll go through each of them. So I mentioned about SQL results cache. So we can auto-cache, but most importantly, we can auto-invalidate. No code changes. We can do automated failover. So SQL Server always on. We complement that, and we can failover faster. If any of you are deploying Postgres, may be familiar with pgpool 2. You can imagine the difficulties that it could have because it requires development work for pgpool 2 and pgbouncer. It is free and open source, but it takes work. So you can think of us as a pgpool 2 and a pgbouncer replacement. We offer connection pooling, failover, read-write splitting. Okay. And then we recently announced support for batch processing. As caching supports and optimizes reads, we now can optimize writes. And this is particularly interesting for batching singleton DML operations. We can batch them together, send them as a single transaction. And I have a slide on that as well. And then lastly, this is more from a security perspective. Because we see all the queries, we're in the middle, we can provide some excellent, not only analytics, but logging historical data access. We know who accessed what, when. So this is very good for privacy compliance. If you do business in the EU, it helps in GDPR, HIPAA, SOX, PCI. We have a flat file, very easy to export. Okay. So this is how we're deployed. If you have 3 application servers, you have 3 database proxies. We are database vendor neutral. And for caching, just want to be very clear because this gets confusing. Heimdall data is not a cache. We provide the cache, auto-caching logic and the invalidation logic. You choose the grid cache of your choice. That could be Amazon Elasticache. It could be Redis. It could be GridGain. It could be Elasticache. It could be Oracle Coherence. Okay? Or it could be in memory. So you choose the cache of your choice, and we will cache the results into that cache of choice. Make sense? Okay. So we have no bias in terms of what you want to use. These 3 proxies are controlled by a central console, for which I'll show you in a demo. And so what's really nice is the data plane is very separate from the control plane. So if the control plane were to go down, the data plane will continue on the last configuration that was programmed. These are completely separate. If any of you are deploying microservices, the way you would deploy it is you would put a proxy in the host, application host, and the microservices would all point to the database proxy. let's get into application side SQL caching. And to answer your question, going under the hood, we cache at 2 levels. Okay, the first level is we cache at the local memory of the application server in RAM, and that's what we're doing is we're caching the hot objects. And then for any spillover, if you have large data sets, it'll spill over to the level 2 cache, which would be the grid cache of your choice. It could be open source, it could be commercial, it could be any of these grid caches. Okay. Now, I think there was a question that was asked, well, how about if I have 1,000 application servers and 1,000 proxies with it? How do I keep cache coherency? That's where we leverage the grid cache. We don't want to invent the wheel, so we're going to use their pub sub as a messaging bus so that whenever there's a write to the cache on one of the app servers or any of the app servers, they will communicate with each other through pub sub to invalidate that table. It's done automatically. So there's no more complex coding of your application on what to cache or what not to cache, or your TTL or expiry, which is a pain. It's all automated. Yes, question?
So this invalidation, it might be asynchronous, right?
What do you mean by asynchronous?
Like if you write something and there is a query on another app server, will it immediately see the change or?
Great question. So I've got that question before. So what ends up happening is whenever there's a write, it will be communicated to the rest of the cache, right? But then your question is, how about if there's another write or simultaneous writes? What do you do there, right?
No, what if there's a read on another app server, right?
Yeah.
But that data was updated, right?
Yeah, got it. Right. So it'll read from the cache.
Right.
So and that's okay. So if there's a write to one app server and there's a read from another app server, it's okay, because we invalidate the table before the write even occurred on the database. So remember, this is on the application tier. So the invalidation will happen before the write even happens, is even executed and committed. Okay. So what that means is that maybe we're going to invalidate sooner, which implies maybe your cache efficiency will not be as good, but you still maintain data integrity. Okay?
So before writing the data, you make sure it's invalidated in all the distributions.
Yeah. Yes.
Sorry, a follow-up question on that particular one. So this kind of assumes that all the reads and writes go through your database proxy.
Absolutely.
And not like command line tools like SQL+.
Yeah. So the assumption here is that a database proxy, whichever one you use, has to go through Heimdall data. Well, you could do that. Okay, so let's talk about that. So we've had customers say, well, there are certain applications that write directly to the database, and it's not going to go through a database proxy. It's not going to go through Heimdall. Do you have a solution for that? We do. You can provide. We do provide like a database trigger, for which we will poll the database for any changes to it. And then what we'll do is from there, we will invalidate the local caches. Or you can create a service that whenever the database is written to, it can communicate to our central console, and then we'll do the invalidation.
For Oracle, sorry to take a minute on this one. For Oracle, there's a specific one, which is called DCN, data change notifications, that the database can propagate to whoever is interested in listening to that.
Yeah.
But I'm not sure if other databases provide similar kind of capabilities.
Yeah. Well, we have a trigger, so it's the same means of doing that whenever there's a change. We're okay? All right. Any questions about caching? So it's 2 levels, okay, of caching. And someone asked me today at the booth, what's the size of the local cache? So number 1, it's configurable. And number 2, what we found is it's a relatively small footprint. It's probably around 50 to 250 megabytes. Not a lot. Because people are concerned that the cache, it might be very large, it might be very expensive, and you might have to have a large set of RAM, but you don't. In our use cases that we've seen. Now, what we do is we use real-time analysis, and we analyze the query frequency and the variability. So if the query doesn't change much and it happens a lot, then we're going to cache it. We're going to cache the results. And what we're going to also do is measure the relative performance between the cache and the database. And let's think about this. If there's a cache miss on the grid cache, Heimdall data, and then you have to go back to the database, that's not good. Can you imagine the latency from there? That's going to more than double the latency. So what we do is we're going to ensure that there will not be a cache miss when you go into the grid cache. And if it's not there, we're not going to go there. We'll go straight to the database. So there's a lot of checks, a lot of algorithms that we do to ensure that if we're going to cache it and it's going to be served out from cache, you're going to get a performance benefit. The other piece that we're going to provide, and I'll show in the GUI, is that we provide recommendations. So we can provide recommendations on the queries that you can cache, and you can click on the button. You can take some of those recommendations, or you can take all of the recommendations. The other piece, too, is you can put it on aggressive mode and cache all. You can cache everything, and that's what most of our customers do. You can't really beat our mathematical algorithms. So most people just say, Heimdall data, just cache everything. So here's an example of our GUI. These are the recommendations, and you would just click on the cache button, and it'll automatically create a regex rule, and it'll begin caching. Okay, it's as simple as that. And what you'll notice here in the query response time, it's currently taking 700 microseconds per query on the top two. And once I started caching it, it turns gray. And the results here is 700 to 70 microseconds. So we're talking a 10 times improvement in response times and a reduction in database load. This is just an example. Yes?
And this was, in this example, you're only showing us if you're not saying cache everything, right? This is where, okay.
Yeah, I'm just giving an example of 2 queries that you clicked on, or 3 queries that you clicked on.
You would only have to do this if you didn't say cache everything.
Correct.
Okay.
Correct. There are those who, there's not a lot, but there are those who are picky,
yeah,
and that are very, they have security issues in terms of just making sure that they're not going to expose data, so they'll pick on the ones they want to. But most that we've seen is just say, just cache everything. All right, I want to cover a few use cases, and then I'll hit a demo. All right. Yes?
So let's say, I as a customer of this particular tool, I go against my database and start caching these things. Now, I know that the database is a single source of truth as far as my queries are concerned. Now, the cache has an additional kind of a snapshot or a mirror of what I would get from the database. Now, let's say I have a transaction and I see different behaviors, either with the cache, without cache. Now, how do I start debugging those kind of scenarios?
Okay, so when you're in transactions, I would say that be very careful. So this is typically, know what you're doing. Typically, especially even with this use case of read-write splitting, because you have a lot of reads, a combination of reads and writes before you do a commit. Know what you're doing before you're caching. Okay, so typically you want to be out of transactions, and typically you want to, if you can, don't be in stored procedures as well. Right.
So one thing I wanted to mention, Oracle actually also has a client cache as part of the OCI client that keeps result sets in the client, and it uses the same technique the gentleman behind mentioned. Uses database change notification to invalidate that cache. So how is this different? What is unique about this compared to that approach?
I don't know the client-side caching of Oracle, but what I would say, number one, is that it is database vendor neutral. Mm-hmm. So we support any SQL database. The second one, too, is I don't know how you would handle the small cache on each app server acts as one large cache. So they're communicating with one another. I don't know if Oracle would support that. Okay.
Oracle, it would already on that app server.
Yeah. So if there's just as this gentleman had mentioned, if there's a write to one of the app instances, that proxy that was written to, that has the write, will communicate with the other local caches to invalidate that table.
But if the write happens somewhere else, like the write happens on the database directly, how is that write reflected in the cache?
I answered that already. We would use it, there could be a service that you created to inform us of the proxy to invalidate it, or you can use a database trigger.
Okay.
Yeah.
That's basically how the timestamp cache works.
Yeah.
Throughout a refresh.
Yeah.
Use triggers in your database.
Yeah. We don't recommend triggers. I mean, because we have such an elegant way at the edge. You would probably know more than I would, but DBAs hate using triggers. It's just a dangerous thing, right? So it's really a last resort. Typically, it's doable, and I think you can be done. I think people just avoid it. So if I think this type of solution is a lot more elegant and less risky. Yeah. Okay, let's talk about read-write split. I think you'll be interested in this. Has anyone done a horizontal sort of fan out like this before, where you have separate writes from reads? It's the way that you scale out your data tier. So I mentioned about read-write splitting. We are SQL aware, so when we will direct and route the writes to the write servers and the read to the read servers. Okay. If you didn't have a proxy, then you would have to change your code, application code, most likely, to do that. Let's say you wanted to add a read replica, another one, a fourth read replica. Well, how does it know? Well, you would have to modify your code to do that. Okay. Another very beneficial feature is we have replication lag detection. So if you have a write followed by a quick read, maybe that the read has not been updated with the most fresh data. So there is a risk by which when you did a write and you did a quick read, the read's going to read stale data. Does that make sense? So what we do is we have a lag detection window that when you do a read and it falls within that window, that read is not going to be coming from the replicas, but it's going to be coming from the write server. So what we're doing here is guaranteeing fresh data on any read. You guys with me? So that's a nice piece of logic to guarantee fresh data. And again, this requires no application changes for this type of use case. All right, let's talk about asynchronous DML batching. So the idea here, and some of you may have seen this already, it's at our booth, it's the ability to batch DML operations. And this is all policy driven and all configurable. And in this example here, we are batching up to 4 singleton transactions. The way we do it is as the transactions come in, we're going to batch, in this case 4. We're going to spoof the application and say, done, taken care of, it's been committed. And on a separate thread, we're going to commit that batch operation. What we found in testing with customers that there's been a performance improvement up to 20 times, sometimes 50 times, just based on this. And this is really for a use case, typically in data analytics, whereby you have a lot of single transactions for a bulk transaction to a table. And we're combining all those singleton transactions into a single transaction. And so you're saving on the commit overhead, if that makes sense. We found that commits are quite expensive.
So this kind of assumes that your session is not set up in an auto-commit mode. So you kind of detect that it is not set up in an auto-commit mode, so it's okay for you to batch the transactions.
Yes.
And batch the commit, the DML operation.
The DML operation, yeah.
The DML operation. But then you would also detect that, let's say that you do a DML followed by a select, right? So you know that that select may want to have the latest data that's been there in the particular transaction. And you have no way of knowing what the data changes have been made in the previous DML. So that would also trigger a batch commit into the database.
Right, so this would not be in a transaction. These are just singleton transactions. And again, you have to know what you're doing, right? So it's very, very key. It could be dangerous, so you have to know what you're doing. The other one too is this probably wouldn't be appropriate for financial information, financial banking, because a good use case for this would be sort of like IoT. You have thousands, millions of devices coming in, and if you drop a few, it doesn't matter. But for finance or important data, because we're spoofing it, right? Once we tell the application, hey, we will take care of it, maybe we didn't take care of it because there was some type of failure. You need to be able to say, that's okay. That's okay. Yes?
Yeah, so regarding that, how do you all ensure that that's what persisting? What if there's a failure after you told the application?
Okay, so the question is what happens that even though we told the application that it was successful and we committed it, and it didn't write, okay? An exception is going to be logged, it will be removed from the batch, and the transaction will be restarted. That's got to be acceptable for your use case and for your application. That's why I gave the IoT. Okay. So for web apps, that tends to be okay. E-commerce, non-financial.
But it's entirely possible that your application, I don't mean the end application, but your process, the one that's handling all this, died between the time it's spoofed and the exception was logged and so on and so forth.
Correct.
In which case the end application will never know, right?
That's correct.
Whether you actually did anything or not. And you don't have any exceptions to remove it from the batch and restart the transaction and so on.
That's correct. So let's say that's even a more extreme example. That application must be, or the end user must be willing to accept that. And that's why I think IoT use cases would be very appropriate. So you're getting tons of data, but if you lose a small window of data, it's okay. Okay. So this use case is not for everything, but it can be, this is really geared for performance, not for data integrity. All right. And I got 10 minutes, and can I give you guys a quick demo? Okay. I can find it here. Any questions as I get started? Ooh.
Do you do any query rewrites?
Any?
Query rewrites?
Yes, you can. We can do something called, the question was, can we do any query rewrites? So we can do query transformation. So the use case would be as such. You have a new build, and you push it out into production. 3 o'clock in the morning, the web app goes to slow crawl. And then you get called page text or whatever. Well, instead of, and you go into our analytics and you find out where the slow query is. Instead of getting the developer to fix the code, check it in, test it, and put it into production, which takes a long time with processes, you can do a quick fix as a Band-Aid and say, I know that's the exact query that's causing the problem based on the Heimdall data analytics. You can say this query equals that query. So every time we see it, it transforms it. We do that within runtime without any application restart.
But you don't use any of the Oracle CBO techniques.
No. It's a very simple regex of this query equals that query. Yeah. Okay. So in this is a picture of our GUI, and I wanted to start here and show you that it's JDBC based. So what's going to happen is in your application file, you will point, it used to point to your vendor JDBC. Now you're going to point to the Heimdall data proxy. And then from the Heimdall data proxy, we're going to point to the vendor JDBC. And that's what the JDBC URL here. And that's the Postgres JDBC. It's just that one line. Okay. Then what I'm going to do here is I'm going to go into the dashboard. And I'm going to show you that the queries per second is about 450, and there's a 0% cache hit rate right now. And I'm going to go to the rules, and this is how simple it is for caching. I just click on this cache rule. So logging is turned on. You can also have execution plan. If that interests you at all, we can also get the execution plan. But it's just really this one rule, and I'm going to commit it. And let's see what goes on here. What's the result of this caching? What you're going to find here, it was at 450 queries per second on this Odoo app. It's an e-commerce app. Now the queries per second should be about 2 times that, just through caching. What's even more interesting is the cache hit rate is at around 95%, which is extremely efficient, implying that only 5% of the queries is hitting the database now. Okay, so you're getting a trifecta of things. You're increasing application response time because the queries are being served out from the application tier. You're increasing database scale, okay, because you're doing more with less. And third, because you're increasing database scale, you're saving database costs. Okay, get 3 things from caching. Let's do analytics real quick. All right. From the analytics here, you're caching all, and what these guys are what's being cached. And what this is telling us that this is getting a 99% cache hit rate, 100% cache rate. This is our query. And if you want to drill in more into it, for developers, you have the whole query, and you also have the query extract plan as well. I was wondering if this interests you at all. Does the query execution plan interest any of you guys? So, not to say you can't get it, but it's a lot easier to have a single pane view of the query and the query extraction plan rather than get this from your DBA. That may take a lot of processes and permissions to get it. Now you all have it full visibility here. The other piece that's really nice is this visibility that you have of let me see. The DB time is, sorry, the overall, yeah, the DB time of 5.3 milliseconds represents the response time from the application side, because that's where cache is being serviced. But what we want to find out is where the bottleneck is. And so what we can also, and not bottleneck, but where the latency is happening of the 5.3 seconds. So if I click on data side statistics, DB side statistics, and analyze it, what I'll find is the overall response time from Postgres is 0.1. So you have 5.3 on the app side, 0.1 on the database side. Where's the latency? Pardon me? Let's do it this way. Let me reanalyze. So the DB time took 4.1. The overall response time was 4.1. So actually, when it's 4.1 and 0.1, what we're saying is that the network latency in between is the bottleneck. That's the point I was trying to make. So that we know that it's not the database isn't an issue, it's only 0.1. And we know what the cache time, it's 100% cache hit rate. So we know that it could be a cloud latency or the latency issue. So my point here in terms of the mathematics is you can deduce where is the SQL bottleneck. And if you guys are in any large companies, it's very easy for developers and database owners to point the finger and say, hey, where's the problem? And this can help identify where the general location from a latency perspective where the problem is. It could be from the database side. In this case, it's not the database side. It could be the code, or it could just be the network latency. Yes?
As part of their analytical tools, I mean, I understand the tools are kind of geared towards what you offer. You can go one step further and then take a peek into what the database itself offers. For example, Oracle gives you the AWS reports. So you could kind of, I don't know if you're looking into that, but we can
We could, but I mean, I think that's a database in terms of the schema and the various views. That's really a database thing. I think our focus is really latency and possible queries that may slow it down that could be solved through caching or possible transformation. So I mean, obviously the sky's the limit of what we can extract, but we also want to keep our boundaries, right? Oracle has some great tools, and in fact, they need to be careful to what level we want to copy, and have duplicate functionality.
I have one question.
Yes.
How fine-grained is your invalidation tracking? So if I have a result I've cached that's based on a join with a projection of some columns, and then I have an update to one of the tables that participate in the join on a different node, do you invalidate the entire result set, or do you have something to track that the update was actually one that could have affected that result set?
We wouldn't invalidate the whole table.
The whole table, okay.
Yeah.
So any DML on that table would result in invalidation.
Yeah, we had thought about being able to invalidate from a query level, but it's a lot of work, and I don't know if that would give the customer the return on investment from a.
One thing you could probably do with the simple case would be if you're caching a set of columns, some from the base table, and some other column gets updated, at least you could know that the cache result is still okay. There are cases like that. For instance, times then we see that a lot. People cache a projection of a table, and if the updated column is not part of the projection, that cache is still fine.
Okay.
But that's required to track the columns that are being cached for each table.
Yeah. Yeah.
So today it's whole table based. Okay.
Yeah. It's table based invalidation.
Question for the caching. Do you just cache the entire result set what you'll get, or like if it's a join? Do you all cache the final result of the query?
Yes. We cache a final result, and it has to be the exact query.
Right.
And so we don't try to fiddle around with ranges or anything, because we don't want to affect adversely the data integrity. So it's got to be the exact query. Okay.
Can I ask one more question? Sorry. What about synonyms? How do you handle that? So cache a result based on the synonym, but I update the table through the original name to a different node. Is there a way to track that?
I don't think so. I don't think we can support that, but I can check. Yeah.
That's where it gets very complicated, because then we do this in times 10. You have to bring in a lot of metadata from the database. Basically keep track of the table, the lineage, the other synonyms, views potentially. And that's another problem is views.
Yeah.
You have queries on views which are composed of multiple tables underneath.
Yeah. In terms of our space, the data proxy space, we don't see a lot of Oracle. And the reason why is that this caching tends to be more amenable to web applications and e-commerce.
Yes, I understand.
And Oracle tends to be a lot more transactional in nature and more back-end rather than web-facing. So as you know, web apps tend to be application talks directly to a database, whether it be MySQL or Postgres or SQL Server. And that's not Oracle's bread and butter, So we don't see that as much Oracle.
I'm just asking in general, because MySQL has the same issue. You have synonyms and views in MySQL.
Yeah.
And you could have an application, one module that uses a synonym, one that uses a different synonym potentially.
Yeah, let me look into that. I don't think we support that. Yeah. Any other questions? Yes.
In the latency, would you be able to map end-to-end exactly where exactly it's spending time? You said it's 0.1 on the database.
Right, and we know that's not the problem.
Right, but would you be able to say how much time it's spending in the code on the server side?
Yes.
And the network latency, and there's also code on the client side before it renders.
No, so that's for me that was a prior life. So on the HTTP side, between application to client, that's a different tool. Receiving the data from the database. Yeah. Rendering, yeah, that's a good distinction. Yeah. Any other question? Thank you.